Okay, so let's look at chapter PE number 4. Um, we need examples of quadratic inequalities with all these different types of solutions. So it's almost like working backwards now. I give you the answer and you got to give me an actual inequality that works. And it's got to be quadratic. So, start simple. The simplest quadratic that we have is x squared, right? Well, let's try something. What if I just did x squared is bigger than 0? Right? Well, that's true almost for any x that you can come up with, except for x equals 0, right? So uh, if I do this, now it's true for every single number there is, right? Every real number. So that's actually an answer to part A. If I do x squared is always positive or 0, well, that's just always true. So that's a good example right here. In one of my classes, somebody once said, pick a negative number, right? Something like this. You could have done also x squared is greater than or equal to -4, right? Because anything squared is always non-negative, so that works too. Um, now we need one that has no solution, right? Well, how about this? X squared, well, that can never be negative, so let's make it smaller than 0. Or we could even do something more extreme. X squared is smaller than -100, right? There's no way either of those are ever going to be true, so no solution. If I wanted to have exactly one solution, well, we can actually kind of tweak what we have here in the first two, right? Exactly one solution would be something like this, where it hits maybe just at one point. Maybe I just want that to be my answer. So if I have x squared again, that's x, this is my y equals x squared here, and I only want it to hit at one point, I only want it to have one answer, well then let's make it equal 0. But I'm not allowed to just do equals because then it's not an inequality. But I know it's never negative, so if I do this, now I only get one answer when it's at 0. Right? It's never below the axis, so it's never negative, but it is equal to 0 one time. D, E, and F are all related in that they use the same kind of idea. So for D, I'm going to draw a simple quadratic that goes through -2 and 5. So let me put this in a different color. Let's say it looks something like that. Right? Now the easiest quadratic you can come up with for this, right? Since it's a parabola going upwards, it's going to have a positive x squared. But I don't even want to write it out x squared plus something x plus something. I want to do this. I want to say y equals, and then leave it in factored form, because that's going to be the easiest way to deal with it. And if -2 is one of the zeros, then it's going to be x plus 2 here. And since 5 is one of the zeros, I'm going to have x minus 5 there. And if you wanted to test it, if you're not convinced, make y equal 0 and solve that thing, and you're going to get -2 and 5. And since when you multiply it out, the x squared term is positive, it's a parabola that looks like a happy face. Okay. So now what I want is I want to somehow lock in everything between and including -2 and 5. So from here all the way to here. Right? I want all that green stuff taken care of. Well, that happens when I'm looking at everything that's 0 or negative, right? Anything below or on the y-axis. So if I say, let's look at x plus 2 times x minus 5, and I want that to be less than 0, then what I've done is I've taken care of all of this part. And if I say let it also equal 0, now I've taken care of the parts that are on the axis. Okay, so that goes with this one. Now let's look at E. So E, I'll draw another simple graph. I know -1 and 4 are going to be the keys here. So here's -1, here's 4. I'm going to draw my parabola. Again, I'm just trying to keep it simple, so always happy faces. You could do it upside down and throw a negative in front of the whole thing, but that's just kind of complicating it. Now, what I want here is I want my solution to be everything from -infinity to -1 and 4 to infinity. So on the picture, That's all of this stuff, not including the 1, and then the 4 and all of that stuff. Okay, well, the equation of this parabola, if it's the simplest one I can come up with, is going to be x plus 1 and x minus 4. Okay, so we have that at least. So if I write here x plus 1 and x minus 4, well, I know that that's going to be involved somehow. Now I just got to figure out, do I want it to be positive or negative? Well, in the picture, these things that I'm trying to use here are positive, and they're not 0 either. So I'm going to say make them positive. And that's going to be the blue parts of that parabola that I shaded there. So that works. And then for the very last one, f, so this goes with that graph. For f, 0 and 4 are going to be the keys. So let me draw this. Here's 0, here's 4, 0 and 4. I want my parabola to go right through those. If I keep this simple, y equals x times x minus 4. Really, this is like an x minus 0 there. Okay, and I want it to be everything from negative infinity up to and including 0. So it's all this up to and including the 0. And then the 4 is included, and it keeps going all the way out to infinity. So that's everything above the axis and on it. It's everything that's 0 and greater than 0. So I'm going to say, let's look at this. X times x minus 4 should be 0 or greater than 0. Just like that.